Hello, my goal here is that I want to show you how to use lookup pops in Touchdesigner to create an effect like the one you're seeing in the background. However, as I've recorded segments of this tutorial many times, I end up explaining my thought process, which I think is really important, for like almost 20 minutes before I actually make some operators. So I'm going to try a different approach and maybe just do the whole thing live, and it'll just be an experiment to see how well this video is received. So anyways, this is the network that I'm going to try to recreate here. I'm just going to bypass everything, and I'm going to show you the reference for where I kind of got the visual inspiration from was this artwork that I saw on my social media feed, and I'm just going to try and show you how the lookup pops were used to create this effect, and yeah, hopefully it goes good. Looking at this effect, I saw some circles and I thought it'd be kind of cool if they fell down into the screen, stayed there for a little while, and fell out again. And I thought these lines that are horizontal and they're at fixed lengths, I thought it might be interesting if they would fly into screen, stay there for a little bit, and fly out. And then I kind of like the texture of these random dots that look like they're on a grid, and the kanji and the color scheme and all that. Yeah, let's just try and make something like that. I want to cover how the lookup chop works, because if you understand how that works, it might help you understand how the lookup pop works. So I'm going to put down a constant. I'm going to put down a noise chop and a lookup chop. I plug this guy in here, that guy in there, and then for visual representation, I'll put a trail down here. The constant, how it works is basically as it goes from 0 to 1, it will look up the values from this graph here. As it goes from 1 back to 0, it does the same thing backwards. So I wanted to do that in pops. How do we do that in pops? Because pops are all 3D. Well, let's try to do it from scratch right now, and we'll encounter problems in real time, and I'll try and show you how I solve them. So first I'm going to put down a point, then I'm going to put down a curve pop. Now, why do I want to use a curve? I'll try my best to demonstrate it with paint. If you are experienced with particle systems and you think about this graph horizontally is the axis of time, and then vertically is an axis of position, if you're using particles and gravity and feedback and stuff like that, your points are going to start to exponentially fall faster and faster and faster. Or if they just have a constant velocity, they're going to fall like this. But there's never going to be a time where they actually stay in screen for a certain amount of time. They're just going to always be falling. So what I kind of want is a movement where the circles will fall into screen, stay in screen for a little bit, and then continue falling out of screen later. And I also don't want every single circle to fall in at exactly the same time. I want some of them to fall in later than others, and I want some of them to fall in earlier than others. So I want basically something that resembles a curve like this, which is an S-curve. So here is a curve, here's a point, and let's put down a lookup attribute pop. The lookup attribute pop, we're going to plug the point into the top, we plug the curve into the bottom, and this is basically what I was struggling with for a really, really long time, is figuring out how to make this function the way I wanted to. So I'm just going to show you the answers now that I've already sort of figured it out. So this point, as it moves along the x-axis, is what is being looked up here, and we can use that to say that the output on the y-axis, position 1, that the y value from this input becomes the output of this lookup. So as I move from 0 to 1, let's maybe pull this out a little bit and maybe turn on pop points so it's easier to see. As this moves along x, you can see how it kind of follows that curve. So now what I want to do is to make it so that I don't have to move the point along the x direction. I want things to just kind of fall vertically. I don't want them to fall horizontally and vertically at the same time, if you get what I mean. What we need is basically to not look up the x position. We want to look up like some other attribute. So I'm going to set this position back to 0. And I'm going to introduce a new operator here. It's going to be an LFO. And the LFO is going to be a ramp. So the value goes from 0 to 1. You can demonstrate that here with a trail. It goes from 0 to 1. And as I make the frequency of the LFO smaller, like 0.1, it will very, very slowly increase from 0 to 1, and will drop all the way down to 0 automatically when it hits the top. Sorry, just went to go fix the camera real quick. So now what I'm going to do is turn this chop into a pop. And normally the values from a chop are going to try to be turned into a position. But in this case, I don't want to move the position of the point. So I'm going to clarify that it's a channel 1 and that the attribute it's going to create is something called val. It can really have any name, but I'm just choosing val for right now. And we're not specifying any position, okay? This is just a pop with a single value attribute. And then what I'm going to do is I'm going to combine this attribute with this attribute using the attribute combine pop. So from the first input, we're going to take val and make sure that that becomes val. From the second input, we're going to take the position and make sure that that stays as the position. And then we can plug that into here. We're going to change the lookup attribute. We're going to say instead of looking up wherever the point moves along the x direction, we'll just read the raw value attribute. And as we read the val attribute, we can see kind of nicely here how the point kind of goes up from 0 to 1. But it goes up in a unique fashion. It goes up following this curve in a certain way. And what I mean by that is if we change the alpha of this curve, you can see that it stays flat at 0 for a longer period of time, and it stays up at 1 for a longer period of time, and it kind of has a sharper acceleration here. So what that means is the point kind of almost looks like it's an elevator. It gradually ramps up its speed as it starts going up, and then once it approaches the top, it starts to decelerate, which is a really nice movement that I like, and that's why I really wanted to opt for using this S-curve. My next goal is that I want to make multiple points. So it is glitching out a little bit here, and I think it's just an artifact of me recording, so try your best to ignore that. But I'm going to connect this to a random pop here, and I'm going to say give me 5 extra points for every single point in the original, and set only their position in the x-axis. Give me a random x value between -1 and 1, and if I change the seed, that changes as well. And I only need to create one random number, so that will at least get rid of that warning. And again, yeah, try to ignore those glitching out points. But every single point is now moving at the exact same time, which is not what I want. That is because if these are connected to a dat2 pop, every single point has the exact same value. So we need to kind of find a creative way to make it so that every point has its own unique value. So the way I'm going to do that is by stepping out of the world of chops and doing it instead. I mean, there's probably a way to do it in pops, but I find it simpler to do it in tops. The way that I propose is using a ramp top, and yeah, let's just delete this LFO, delete this trail, delete this chop too. We'll start with this ramp, and I'll just make a chop that will be a constant, and we'll just say that this is our number of points. Let's turn this into a 5 so that we're always using 5 points. And this ramp will use the number of points to control the number of pixels in this ramp. So it will only be 5 pixels wide, 1 pixel tall. Set this to nearest pixel so that we can see every single pixel individually. And we'll also use this number to define how many extra points per source. From this ramp, if we convert the top to a pop, and we say that the first RGBA contains color, yeah, okay, oh no, let's say that the color represents something custom. So from ramp 3, those RGBA values, I mean, we don't even really need all of them. We can just use R, because that's basically the value of whiteness. That R value is going to represent the val attribute. Yeah, so now if we connect this to a pop2dat here, we see every single val is different, and that is because this ramp here has 5 different pixels with different values. And let's just make it 32-bit so it holds a little bit more precise information, and we'll change the phase of this ramp using abstime.seconds. Maybe multiply it by 0.1 so it's like a little bit slow. Yeah, there we go. So now every single one of these values is starting off super duper bright and over time slowly fading. And so pretty much what that means now is if we combine these vals with the original position, and then we also need to swap the order of them, then we should have 5 points. Okay. Because we've got 5 points here, but we only have 1 point to start, let's move the position of this random over here. So 1 point generates 5 random points. Those 5 random points are then attribute combined, and then that combined attribute then goes to look up their positions. So now here is that magic sauce that I was looking for. Every single point is kind of falling down on its own time. That's great. None of them are falling like a consistent, like they're not all falling at the same time. That's exactly what I want out of this. So now let's maybe speed that up a little bit, maybe like times 0.3 for the phase, so that they're all falling a little bit more. And if we increase the number of points, this is a great reason to use pops, is because now it can be dynamic. So if we make like 50 of them, then now we've got 50 points that fall, non-uniformly, which is great. So now that they're all falling non-uniformly, what I want is to also introduce a point in the middle where they will stay for a little bit and then fall a little more afterwards. So that means that this curve needs to be changed a little bit. What I'm going to do is I'm going to just copy and paste it actually. For the second version of the curve, I'm going to say that it actually starts at 1 and then it ends at 2. So it's basically the same as the first one, just a little bit higher. Then let's see what happens if I merge the two of them. So I'll merge that and that. And if we just plug that in, yeah, I mean, that's already doing exactly what I wanted it to do. What a nice coincidence. One thing that I did in the previous version of this, which now actually I realize I don't really need to have done, is I used a transform to just kind of get rid of the X movement of this so that it kind of all became just linear. And then I put, another transform here and make it just one continuous line. It's not really going to impact the output so much, but it's still nice though that you can see that they start, move to the middle, stay for a little bit, and then they stop, and there's no real giveaway that they're all following like a repeated pattern. But if you were to record this for like 1 minute straight, you would see that this actually does create a perfect loop. A loop in phase with this ramp here. So anyways, great. Now we've got something here that we can use to look up the position of all the circles. So let's start making some circles. First, I'll put a circle down here. I want it to be completely full. So to do that, I want it to be a surface. And maybe I'll give it some more divisions so it's a little more round, maybe like 80. We'll take this circle and we will copy it. And we'll copy it for every point. Now there's too many circles and they're all too big. So what we can do here is in the copy pop, there is a template that we can use to control the scale of it. So what we want to do is basically, after getting all of these points that have their position and a value, just connect this to a random. And with the random, we'll just specify that we're going to set a brand new attribute, and that is just going to be the scale, the capital S. So the scale is going to be by default from 0 to 1. Since I know that's still going to be huge, I'm just going to make it all the way down to like 0.1. So we've got this scale value here. And then in the copy pop, we're going to turn on the template scale, and it's just the scale attribute. So now, cool, we've got some circles here, and that's kind of interesting that they are all not uniform in size. Some of them are more like ovals. So what that means is that the scale is probably, yeah, it's a float 3. So it's generating 3 random numbers instead of 1 random number. It's generating like a random X scale and a random Y and a random Z. So to fix that, when we're generating the scale, instead of generating 3 components, we're just going to have it generate 1 component. So now these are all going to be uniform circles regardless of their size. Next up, what I want to do is all of these points, I want them to slightly be offset in the Y direction. So some of them be up a little bit, some of them be down. You can probably just do that here if you connect a random to it, and we say take their position in the Y direction and add a little bit of randomness, not like a huge amount, but maybe add something between like +1 and -1. Yeah, plus 0.1 and plus -0.1, so that they all are clearly in their own stages, but they're just not in a perfect line. Maybe a little bit bigger so there's some more diversity. Maybe even more than that, -3 to 0.3. Yeah, that's probably fine. After that, what else can we do? We can probably also give them a color. Can we do that just with another random? We'll set the color.r value. If we set the color.r value, it is going to give them varying levels of redness, which means that we want the amount of greenness and blueness to always be at 0. So instead, what we'll do is before adding that random color R, we're just going to create an attribute for color. They will all be straight black to start, and then this random here, which will just be a single random, will add a little bit of redness to all of them, not uniformly. That means that in the output here, do they maintain their color? Template attributes. Okay, yeah, if we copy the color attribute, then that color attribute will persist all the way to the end here. And maybe we can just also mix it up by making sure that the seeds on all these things are just slightly different so that there's not any kind of weird artifacts of uniformity. I'm liking that. I think this already looks pretty good. I'm going to convert this into a top using a render simple, and the position of these points could be shifted down. Right now they're going from 2 to 1 to 0, but to kind of center it here in the render, I'm going to connect this actually to a transform, move everything down by 1 unit, and then can also maybe just connect this to a null so that the network is nice and tidy. And this will be circles, maybe, yeah, is all we need. Cool. So put that in the background. Let's give it a nice white background like this with full alpha, so it's purely white. The points can be, maybe the camera can be a bit closer. Camera distance, maybe 2 is fine. Yeah, sure, why not? Just so that it looks more like the example in the beginning of the video, I'll just make there like 300 circles here. They're falling quite fast, so the speed of this ramp will slow it down again, maybe back to 0.1, maybe even less than that, maybe 0.05. I think that's a nice amount. And then the amount that they are going up and down, I would like it if it covered a majority of the screen, so that random in the Y direction, maybe we'll increase this to +0.4 and -0.4. But yeah, okay, so I think that's a good starting place for the circle effect. And that is basically what I figured out for how to use the lookup pop. So let's try that one more time, and let's do it in the horizontal direction so we can see some of the like subtle nuance differences between those two things. We'll make another constant down here, and this one can be number of horizontal lines. And sure, we can leave it at 300 for now. We'll have a ramp as well, so that every horizontal line that flies through here has a little bit of an offset. That means that we will set this to be a reference to the number of pixels in that ramp. Next, the top two. Yep, that we can keep that exactly as it is. That will be the ramp. For the value, we'll take 1 point, copy it, and combine those attributes the same way that we did before. So we've got 300 points that all have a position and a value. Let's just make sure that they're all unique values. Yeah, okay, cool. So that looks good. Right, these positions, because this is going to be vertical, it doesn't mean that they need to be shifted along the x-axis. These should be started off by being moved along the y-axis. So values between maybe just like 0.5 and 0.5 should be enough, I think. And then maybe we don't need 300. Maybe we'll just do 10 right now for proof of concept. Did that update everything? No, it did not, because this guy is still not referencing the number of horizontal lines. Okay, so now there are 10 points. Great. Then what we're going to do, same sort of, we need to create an S-curve. So we'll create an S-curve here. Then what we want is for this S-curve to actually start from the right side, move to the center, and then move left. So miraculously, I don't really know how this worked so perfectly, but we can actually just rotate this S-curve like 90 degrees that way, and then shift it over by 1 unit. And I think that is enough to get what we're looking for here. So now if we take those attribute combined positions and move them along this horizontal curve, right, when they move along the curve, they should not be following the X position, they should be, or they shouldn't follow the Y position, they should be following the X position. There we go. Yeah, look at that. So they are moving from left to right. I want them to switch direction, so I think maybe if we just rotated this the other way and then moved it over -1. Yeah, looks to be good. So we'll add more points now. Maybe we'll do like 100. And yeah, now we've got a bunch of points that are flying from right to left. And so we would like to add a little bit of randomness in their Y position, or sorry, in their X position. So in this case, we will add to their X position a little bit of randomness. We can maybe have it be something like from -0.1 to just +0.1. I think that looks fine. Then after that, we'll give it the same treatment. We can give them a unique color. So something like this, we'll create a color attribute and then generate a random color for them. In this case, instead of generating redness, we'll just have them generate some greenness. Instead of creating circles, we are going to, let's just make them be rectangles instead. So we'll start with a rectangle like this. We'll maybe make it a little bit thinner, sure, and we'll copy the copy pop over here. So we'll use this as the shape and then this as the position of the shapes. Great. They are a little bit too big, scale attribute is not found, it says. So here is where we added scale. So let's make sure to include that in the pipeline. Nice. Now we've got some randomly sized green rectangles just flying into screen. We can probably put a transform here just in case we need it, and then another null, and let's render this guy out as well. This one will be just the lines. A render simple. Cool. Let's zoom the camera in, maybe the same distance as before. Sure, that's fine. Now I would like more variance in how much they're moving left to right. That kind of offset, that randomized offset from left to right that we're adding, I'm just gonna increase that, maybe -0.5 up to 0.5, so that they kind of show up in random positions. Yeah, that looks good. And then I think to kind of match that original reference, I would like for there to be just more density basically. So we'll increase it from 100 of those to I think maybe 500. And I think that looks all right. To kind of do that effect where these lines offset those circles a little bit, that is called displacement. So what we'll do is we'll take this image and we will displace it with the displace top, using the lines as the displace image. And it looks nothing like we expect, so I always recommend starting the displace weight at 0. We want to displace things horizontally using the color green. So I'm going to change the horizontal source to be green. And I'm going to say that it should displace things horizontally 0.1. And we can already kind of see how it's starting to make the image a little bit more like the reference. It takes the whole source image and shifts it a little bit to the right, so we can just change the source midpoint in the X direction back to 0. And then let's just tweak that amount of displacement to an ideal number, something that's just more desirable. I think maybe a smaller amount is better in this case, so maybe just like 0.02 looks all right. Yeah. Now I'm feeling like there's just too much white in this image, so I'm just going to add some more circles. Let's make it like 500. I feel like there's still quite a gap between the top and the bottom in that whiteness, so I'll change the random amount of vertical displacement for the circles to maybe -0.5, +0.5. And yeah, I'm okay with that. Take this out of the background, take this out of the background, and make this the new background. I think this is alright. I could add some more vertical lines. I'm going to change this maybe from 500 to like 1,000. And cool, yeah, now this is looking a lot closer to what I originally had made. Maybe they could displace by a little bit more, maybe like 0.4 is okay. And now for that final layer of like the pixel grid. So to do that, I'm just gonna take some noise here and I'll make it a 1280 by 720 resolution, and I will play around with the exponents a little bit. Yeah, maybe this is fine. We'll add some transforming to the noise, so ABS time not seconds, have it move by a small amount, and then I'm going to use a limit top here to quantize the position by rounding it to maybe a slightly smaller grid. So now everything's kind of like nice square pixels, so all of the points that would show up according to this would be kind of the same scale. What I'm going to do is I'll take this top, I'll convert it into a pop, and this time the color data of that top is going to represent, the R channel is going to represent something that will be a uniform scale. So And there's kind of a lot of points here. We don't really need that many points. I'm gonna go back to the original noise. I'm gonna change this to be maybe 1280 divided by 4 and 720 divided by 4. So there's just less points here to work with. Yeah. Then we can take maybe a simple rectangle and then copy this rectangle along that grid for the scale. Then turn that scale attribute on, and these values should really be a lot smaller. So maybe we'll take a math and then take that scale attribute and the values as they're going from 0 to 1, make them way smaller so that they're only like from 0 to maybe 0.01, something like that. Yeah, that looks kind of nice. Cool. And this grid itself, yeah, I'm already quite happy with this actually. So I'm just gonna connect this to a null. We'll just call this the grid of boxes and create a render symbol of that. Move the camera closer. Great. And then it could be nice maybe to increase the size of that grid just a little bit more. So maybe from, yeah, up to like 0.02. Cool. And last thing I'll do is I'll just put that texture on top of the original texture. So now we've got this as the final result, which is acceptably close to the original, I think. I think what we can also do is maybe include the raw image, or the raw circles and the dots before displacing them. So that way some of those grid values are also displaced along with those green lines. And something else we can do about the green lines is I'm noticing they're like a little bit harsh on the edges. So I'm going to see if I can give them brighter color with like a constant material. Maybe these circles as well could benefit from having a constant material. Turn this into nearest pixel so that the edges are just like a lot sharper. Well, yeah, I'm not going to be too picky about it for this tutorial. But anyways, so here's the result, I guess. Something I definitely did in the original was I spent a little more time kind of with the color correction, but comparing them side by side, I think I did a pretty okay job. So yeah, anyways, this was sort of a different approach on trying to live code an effect, and hopefully you learned something today. Maybe it gave you some inspiration for how you could use pops, particularly a lookup pop, to create this effect, with the key here being the ability to have points kind of smoothly accelerate and decelerate as they get to a certain position and then move out of screen again. And we tried that in both the horizontal directions and vertical directions. So yeah, if you have any questions, or if you totally hated this format and you never want me to make another video like this, let me know. And I hope you have an amazing rest of your day. The project file I will upload to my Patreon as well, in case anyone wants to support me and download it from there. Thank you for your time, and have a good one.